Okay. Did y'all have a good weekend? No. Yeah, no? Yes? No?
Yes, I did. Oh my God.
Wow.
How was your weekend?
It was so good. Thanks for asking. I just did so many fun things. On Saturday, I went to go play volleyball, and then one of my besties, so he's from Mexico, and it was his birthday and my birthday in August, so his family threw like us a birthday party. Thanks. So I let my 10-year-old like dance the night away until like 1 a.m., which I felt kind of bad about. But his mom was like salsa dancing with my kid and stuff. It was awesome.
Did you have
So great. We actually had hamburgers and hot dogs, so they didn't come through on that, but the cake was like a tres leches, and they sang happy birthday to me in Spanish, so I kept like, I was about to blow out the candles, and then like the song wouldn't be over. It's a totally different song than I was used to, but it was fun. Alright, you ready? Yeah, it just went on and on. Okay, so we wrote down the limits last time, so we're just going to do an example of each, then we're going to find on the homework which ones have this in them. So first one, we have sine 2x over 6x, x approaching 0. If you did substitution, which is your first method, 6 times 0 on the bottom is 0. You'd think it doesn't exist, but it does. Okay, remember, ax over bx you get. Okay, so what would it be here? 2 over 6, which is a third. Okay? Easy, easy. Yep. Okay, so these are the last section because they're kind of the quickest. Okay, one more like that. Limit.
I have a question.
Yes?
1 minus cosine squared is sine squared.
Uh-huh.
That sounds weird.
It's sine, yeah. Yeah, you are correct.
I have a dress.
Okay, look at the next one. Okay, which rule does this look more like? Rule number 1 or rule number 2? Rule number 2. Now, it's not exactly the same, but we can make it look the same by factoring out a what from the top. We can take out a 2. Now, can we take out an x if this x is inside cosine? No. So we're going to take the 2 out, so I'll have 1 minus cosine on top. That looks the same, right? And then what do I need to pull off the bottom? 5. So I'm going to rewrite it like this. Limit x approach 0 of 2 over 5 times 1 minus cosine x over x. Do we agree that that's the same? Factored a 2 out from the top. I pulled the 5 out to the front. And now this chunk is special. Look at your rule. 1 minus cosine x over x. You'd think it doesn't exist, but really it does, and it's what? 0. So I have 2/5 times 0, which is 0. And remember that the difference is a limit that doesn't exist and a limit that equals 0 are totally opposite things, totally different answers. Make sense?
Yeah.
Okay, so get out homework 5. This is what you got on Friday. Flip over to the back. Yes, you needed to?
Oh, yeah.
Okay.
I say yes, ma'am.
Anybody else? You need it? Oh, I didn't say were you already at Berkner? Okay. What's your name? Yeah. Yeah, of course.
Keep saying yeah.
Oh, yeah. Yes, yeah. Okay. Homework 5, backside. Okay, let's do actually let's do 11A just as a warm-up. Okay, look at number 11. Okay, x is approaching 4. What do? E to the 4 over 4. If x is approaching a number, you try to plug that number in. When I plug in 4 here, it works. So I get e to the 4th over 4, done. Okay, letter B. X is approaching infinity. What do?
Flip.
If it was negative infinity, I might flip, but it's regular. Bubba, Bot, and Betsy, which one?
Betsy.
Because remember,
it's an exponential.
exponential, what's that? Power. Powers are weaker than exponentials. Exponentials on top, so it's a button. Bigger on top is none or DNE. Very good. Okay, now look at the next one. Okay, x is approaching negative infinity. This is where your exponentials can turn into little baby fractions. So instead of e to the x, it's going to be 1 over e to the x over x.
Wait, those are the only ones that can do that, right?
Exponentials are the only ones we've looked at so far, correct. Now from here, x is approaching infinity because we already moved our e down. What does this term go to? Okay, so it's bigger on bottom, so it's 0, and 0 divided by anything is 0.
Wait, we do 1 over x at the bottom 0?
Okay, so keep in mind that the bottom is like x over 1. So if you did x over 1, that'd be like it, but it said divided by. So I wouldn't think of it like that. Think about x is getting bigger and bigger and bigger, that's a power. This going to 0 means it's a constant. What's bigger, a constant or a power?
Yeah, I understand. That's like, since it's negative infinity, you can 1 over x.
No, because that's, remember, powers can't flip, only exponentials. So if it's not like 2 to the x or e to the x, you can't flip it. Okay, turn over to the back. Okay, pick like 4. Okay, focus, pick like 4. Which ones are we doing?
24, 29.
16.
Okay, 16.
Wait.
17.
I'll do 24, 29, one more.
23.
20.
Wait, no,
23, you weenies.
20.
That's even harder.
20.
That's even harder.
Okay, I picked 20, fine. Okay, so look at number 16. Okay, I'm going to remind you of the rules that we learned on Friday. Plug it in if that doesn't work. Factor cancel if that doesn't work. Maybe a conjugate. If that doesn't work, maybe a special. Okay, so look at number 16. I try to plug in 2. What do I get on bottom?
0.
0. It could be DNE or it could be fixable. Factor the bottom. How do we factor that?
X plus 2, x plus 2.
Okay, limit x approach 2 of 2x minus 1 over x plus 2, x minus 2. Order does not matter. Then, if the factor on the bottom that's giving me 0 cancels out, the limit's fixed, you get to plug in. Will that happen here? No. So, the limit is? Good. Now, do you remember what happens in the graph when the factor doesn't cancel?
No. That happened when?
That happens when the factor does not cancel out. Now, real quick, let's talk about what if the factor does cancel out? Then there was a hole and the limit is fixed. It does exist. Okay, so go to number 20.
I meant the bottom.
X is approach. Oh, bottom. I was going to say this one's kind of
I
easy.
meant the bonus 20.
Okay, alright. Go to the bonus 20. What's bonus 20?
As long as it's easy.
Oh, okay. We'll do bonus 20. That's fine. Okay, so look at it. How are you going to factor a cubic function?
Split it.
Grouping. Split it. Very good. So group these guys together.
Bro.
Group those guys together. I'm going to see what the first two have in common. What do they both have? They both have an x squared. So I'm going to pull that out to the front. What's left over?
X plus 2.
Okay, plus. Next two little partners, 2x plus 4. What can I take out? A 2. What's left over? Then if these guys match, I can GCF an x plus 2 to the front. What will be left over?
X squared plus 2.
X squared plus 2. Now, all of that was over an x plus 2 at the beginning. So when I take my x squared plus 2 to the back, what's going to happen here? And this was the problem. Now that the problem canceled out, the limit's going to exist. Okay, so cross out, cross out. Negative 2 gets plugged in. What's negative 2 squared?
4.
4 plus 2 is? Oh, wait, 4 plus negative 2.
No, positive 2.
Oh, wait, yeah. Gotcha, maybe. Got myself. Okay, good?
Yep.
Okay, let's go up to number 29, right above it. Okay, that could be DNE, because if I plug in 0, I get 0 on the bottom. It also could be special. Okay, so what can I take out of the bottom to make it look special? Okay, so I'm going to have the limit. X approach 0. Sine 6x over, what does the bottom have in common?
X.
An x. Now, write it like this. What's left over?
6 over
X plus 2. Now, the reason I'm writing these in separate fractions, okay, is because sine 6x over x is special. X plus 2 is a leftovers. What could I put on top as a placeholder?
1.
Now, this is why. Remember the rule. If you have a limit of a product, you can apply the limit to each chunk and then times them together. So my first limit is special. What is the limit? We just did this of 6x over x. 6 over 1, which is just 6, right? Times. Okay, then I move to my second fraction. X is approaching 0. What is 0 plus 2 on the bottom? 2, 1 over 2, and that didn't give me a divided by 0. So I have 6 multiplied by a half. How much is that? 3. So this one is special case number 1. Okay, now, look on your paper. Where is another question that involves special case number 1?
23.
Nope. 27.
Where did 6?
So what I did was I separated this into x times x plus 2. And so then here I got 6 over 1. Here I plugged in 0. So remember, your goal is to substitute. So when I plug 0 into this, I don't get it divided by 0. That's why I'm allowed to do it. Okay?
Wait, but how do you know it's what x plus 2 under 1 and not x plus 2 under signs?
The reason why is because if I put x plus 2 under here, then it's not special. It has to be special. So I want it to be sine ax, which is sine 6x, over bx, which is like a 1x. So if I can make this look special, then I can use that certain rule that you have in your notes. Uh-huh. So it would just be 6 times a half, which is... Okay? Alright, so look at number 27 right next to it. What's this one? Special rule. 5/7, done. Okay? Huh? Sure. Okay, take a look at 24 first. Okay, when x is approaching a number, you try to plug the number in. Pi 6, can I plug it in? Sure. So am I finding the cosine of pi 6? No, what am I finding the cosine of? 2 pi 6. Which is really cosine what? Pi thirds. Yeah? Then you can do your hand trick or unit circle. Pi thirds is here, cosine's on top, so I get 1 over 2. Easy? Okay, look at 23. This is the last one we'll do together. Okay, I have the limit of x approaching pi 6 of x sine x. Remember, if there are multiple x's, you plug what x is approaching into every x. So when I plug in for 23, what will I get? I'm plugging in here and here. Pi 6 times the sine of pi 6. Very good. And then I'll evaluate sine pi 6, multiply it by the pi 6 already in the front. What is the sine of pi 6? Half. What is pi over 6 times 1 over 2? Pi over 12. When you are multiplying fractions, straight across the top, straight across the bottom. Easy?
Yep.
Okay. So the last thing that we still have to talk about from this homework are absolute value functions. So you should have picked up notes on the way in. If you didn't, I'll grab them for you, but I need you to get out your Chromebook. We're going to graph these on Desmos. If you don't have a Chromebook, you can just grab a calculator, or I'll graph them up here in the section. Okay. Yeah, keep your homework up. Anybody need this paper? Yes. Yes. You need everything out, you own. Just keep everything out.
Yeah, but like, I thought you were a step ahead of me.
Okay, so you're getting out Desmos. Go ahead and type this in right here. Why do you hate Desmos?
I don't know, it's just annoying.
What? No.
That was note over.
Okay, Desmos.
No, wait, who was it?
Yeah, sure. Okay.
Oh, it was Steven.
And then like,
And like, where were we?
No.
Like,
note should be taken constant yearly application and processing.
Okay, go ahead. Once you pull it up.
I guess it's pretty.
I think you can like
I mean, we're figure out pricing.
Jerry knows every instinct song. Like this whole hour, he knows hard to like what. Dude, I never saw it.
I think you're
I thought he was going to take a break. That'd be nice. He's not a rapper.
Okay, mine won't connect, but did you guys type it in?
He was he said he was
Okay. Okay, if I was doing this graph right here, we're going to apply our normal rules, then we're going to graph it and see if they still work. So, for example, if I was trying to see x equals 3, what would I do if the bars weren't there? I would plug in 3, what would I get? 0 on the bottom, not allowed, so what would I say? Limit might not exist, or I can factor cancel, right? Yeah. Now again, the bars are there, we're pretending they're not. So I would say, okay, well then that's going to be 2 times x minus 3, right? Okay, if this was a regular limit and all my regular rules worked, then what would happen here? These guys would cross out, and I would say the limit is 2. Okay, now, if you have graphed this on your thingamabob, did anybody do it yet? Who did it? Did you graph it? Who?
I did.
Who did? Can I steal yours? My little thing won't go on there.
Yeah, don't worry.
Okay, look. So we would think that the limit, I'm going to cross this out and put, oh, it's 2. Okay, but if I look at my graph on here, okay, just pretend it doesn't look horrible. What do you notice about the graph? On one side it's 2, but what is it on this side? Negative 2. So do those limits work if you have absolute value bars? No. Those strategies do not work. So I'm going to put, okay, absolute value can cancel, but it creates a jump at plus or minus the y value. So this is what I mean by that. If I did my cancel and get 2 for a regular equation, that would have worked fine. But if you have absolute value bars, you're going to notice that at 3, which is the limit I was finding. It is 2 on one side, and it is negative 2 on the other side. So, if the limit from the left is minus 2, but the limit from the right is positive 2, does this limit truly get fixed if it's an absolute value? No. So what would you put for the limit? DNE. So this limit, as x approaches 3, is actually a DNE. Okay? Even though they kind of cancel out, I don't have an asymptote, I don't have a hole either. I have a jump that counts as a DNE graph. Now let's talk about to infinity. If you're looking at the graph on Desmos, what's my limit to positive infinity? 2. What's it to negative infinity? Negative 2. Now think about your Bobo, Bot, and Betsy rules. If I did Bobo, Bot, and Betsy, this would be a Betsy. I do 2x over x is 2 over 1, but to one direction it's 2, to the other direction it's minus 2. So your Bobo, Bot, and Betsy rules kind of work, but they're opposite. Towards forward infinity, I get positive 2, and towards negative infinity, I get negative 2. So your Betsy almost works, but not quite, because they're approaching different values of 2. One is positive 2, one is negative 2. So, moral of the story is, some of the rules that you use on polynomials still apply for absolute value, but they're kind of edited, okay? So, what I want you to do is, you should still have homework 5 out. There was one question on the front we skipped, because it had an absolute value, and it was number 6. So, take a look at homework 5, number 6. Okay, I can put mine up here if I need to, but it's the limit as x is approaching what? Infinity and negative infinity on a function with an absolute value on it. So if I'm looking at this one, is it a Bobo, Botan, or Betsy?
Betsy.
It's a Betsy because it's an x over a 2x. But towards positive infinity, what will my coefficients be? 1/2. But towards negative infinity, instead of getting positive 1/2, I'll just get negative 1/2. So, here's what you should know. If it is an absolute value, your limits to infinities will be opposites. If one is towards positive 1/2, the other will be towards negative. The only other function you have to worry about are the exponentials that can turn into fractions. Everything else, your limits to the infinities should be the same. Absolute value, they'll come out to be opposites. And then for e to the x or any of those, one will exist, the other one will not. Okay? All right, so the other thing we need to talk about is x approaching a value. So let's look at number 2. Okay, so if this was a normal equation, okay, regular with no bars, I'd factor the top of that. How would it factor? Okay, x plus 3 and x minus 2. We're back on your notes. So the question is, can I, like with regular numbers, cross these guys out, boom, boom, and then plug in 2?
No.
Okay, the answer is going to be no. That is correct. So we want to cancel these guys out because that's a thing. I plug in my 2 here and I get 5. That is wrong. We're going to type into the graph. One side is going to approach 5. What do you guess the left limit is going to be? Negative 5. Very good. So I'm going to graph it on my computer. Oh wait, my internet doesn't work. You graph it on your computer. Or I can maybe do it in one of these. Okay, but type it in. Okay, we want x squared plus x minus 6 over math, oops, delete math, number, absolute value, x minus 2. Okay, ready? If you don't have yours up, you can look at mine. Okay, your graph does like some weird stuff. What value is it going to? -5. Then what happens on the other side?
Bro, that is
Positive
weird.
5. Yes, so weird. So what would you say about your limit at this value? Doesn't exist. They do cross out, but they cross out to positive or -5. Those are not the same, so the limit still doesn't exist. Now, if you graph this on Desmos, it looks kind of weird on this one. I don't know why. Okay, but just pretend. So sketch that on your paper.
Question.
Yes?
So just limit in general, right? If they both end up in a open circle,
Uh-huh.
it would.
If the open circles are the same, at the same height, then the limit exists. But if they're approaching different open circles, you would say it doesn't
Okay,
exist.
and that open circle thing only applies to kind of like the y values. So it's like f of 5 or whatever.
That would be where it would be undefined, if they were both open circles. But your limit can still exist even if
So
there's
even
an
if there's an
open
open
circle.
circle and like a circle in the same y value, wait. So like say like there was an open circle and say there was like a circle that wasn't open.
Okay.
So would it still be?
So the y value would be the closed circle, and the limit would be the open circle as long as both sides were leaning towards that same circle. Yes?
You can answer number 3, right? I mean 2B, right? X, 3.
You're talking about here?
Yeah.
Yeah. So your limit as x approaches that should be a 2. Should be DNE. Because your left and right limits are not the same. So if you'd like to edit that, that should be a 2. It should be this same breakpoint right here. Okay? Now let's talk about to the infinities. If I'm approaching positive infinity, what's my graph doing? Going up. What about to the left? Going up. So my limit to infinity and to negative infinity are both DNE. Is that consistent with the answer I would have gotten with Bobo, Bot, and Betsy?
No. Well, yes.
Look at your powers. Where is it bigger?
Yeah, it would.
Where is it bigger? X squared or X? Who would have won? Top. And bigger on top says none. Did I get no asymptotes? Yeah. So this is still a button. The only thing you have to change your signs on are the Betsy. If you get a Betsy of 3, the other side's -3. If your Betsy is a half, your other side's -1/2. But if it's button, it's still button. Okay? All right, flip over to the back side. Next one. We are typing in x cubed minus 8 on top over the absolute value. X up to the 3 minus 8 on top. We're typing in absolute value, x squared minus 4 on bottom. Okay, ready to graph? Okay, what happens on this side? What does it look like?
Quadratic.
Okay, it looks kind of like a quadratic. I mean at the whole. What is it? You said it. Oh, no, that's what I'm saying. Asymptote. What happens on this side? A jump. You see the difference?
Absolute value part.
Okay, now let's talk about y. Pretend like I hadn't given you this graph and you had to figure it out on your own. Do you remember how to split these up using this formula? Okay, difference of cubes is a special formula that can help you factor perfect cubes. Now, I don't expect you to have this memorized. I don't have it memorized. That's why I put it on the worksheet, so I didn't have to look it up. Okay, but if I wanted to factor this, I would use this formula on top. A cubed and b cubed are my perfect cubes. What is the cubic root of x cubed? So it's going to be an x. What's the cubic root of 8? So it'd be x minus 2 is this first one. And then I just follow the formula. A squared is now going to be an x squared. AB is going to be a 2x. And b squared is going to be a 2 squared, which is a plus 4. Now, again, you do not have to have that memorized. I don't have it memorized. Totally unnecessary. Okay, but on the bottom, how can that factor? Plus 2 and a minus 2. Now, technically they're in bars, so they're kind of protected, right? They can't really cancel out. But if they could, who would have canceled out? the x minus 2's. Let's look at the graph. If x minus 2 crosses out, what happens at 2? There's a jump. What about the one that didn't cancel out at my plus 2? What happened here? An asymptote. So if the factor in the absolute value cancels, it leaves you with a jump. If it doesn't cancel, it still leaves you with an asymptote, just as if that wasn't there. So we're going to write that down now on your paper, but I'm going to sketch it first. Okay? So here's my picture. Negative 2, I'm going to draw in my asymptote. He kind of comes up and then down. That side comes up and stops. This side starts and stops. Both of your special values, though, happen at 2 and at negative 2, the things that make the bottom 0. The difference is, okay, I'm going to write right here that my x minus 2's kind of cancel out, so they leave me with a jump. My x plus 2 did not cross out, so it leaves me with an asymptote. Okay? So my x minus 2's kind of cancel. So I end up with a jump at plus or minus whatever that y value is. Now, I'm not going to factor cancel and plug it in because I don't care. The point is they're the same number, but one's positive and one's negative. So if this is 3, this is minus 3. If that's 5, that's minus 5. But at this factor, at my x plus 2 factor, it cannot cross out. So I still have a vertical asymptote. Now, important question though. All this crap that we're talking about. Does it matter for the limit if it approaches different values or if it has an asymptote? What would I put for either one? That it doesn't exist. So if you are using limits approaching values with an absolute value, okay, most of the time, that limit's not going to exist because if they're approaching opposite values, doesn't exist. If they're approaching an asymptote, doesn't exist. So I want you to put that both of these DNE, but they DNE for different reasons. One of them doesn't exist because of a jump. The other one doesn't exist because of an asymptote, but it really doesn't make a difference. Okay? Now, what would your Bobo, Bot, and Betsy rule be that you would apply here? Bigger on top, and do you notice that at your graph I don't have asymptotes on either side? Okay, so Botan still applies. So this is a Botan, and behavior limits don't exist. They don't have asymptotes. Okay, and that's consistent with the Botan rule that you would have expected.
Wait, so
Okay.
if the thing is consistent and we get it, like why do we still have to do all this?
It's really just more for you to kind of understand how they work. Okay? Alright, very last one. Notice your equation is almost the same, but we're popping a 3 in the front. Okay, now question. If there is a 3, now with this top, can I still use that special formula? Can I still use this special difference of cubes formula? No. So look, watch what happens when I put that 3 there. It messes up the formula. Now instead of having a jump, I'm going to end up with 2 asymptotes. You'll have an asymptote at negative 2 and an asymptote at 2. I'm going to zoom out so that you can see it better because you can't really see it there. So look. You have an asymptote there, and then you have one there. What's this one? Negative 2? What's that one? Positive 2. But because the 3's in there, now I can't use my special formula. Nothing cancels out. Now they're both asymptotes. Okay? So sketch the graph. I'll sketch it on my paper. Okay, we're going to have an asymptote line at negative 2 and at positive 2. On this side it goes like that. That side it goes like that. In the middle it kind of looks cubic. Okay, but the point is that both of those have asymptotes because neither of them can like kind of cancel out, but not really cancel out. So I'm going to put here vertical asymptotes. Because neither one of those can cancel. Okay? And then x approaching infinity would be DNE, okay, which is still Botan. So the only rule you really have to edit are Betsy's. Okay, they're approaching positive or negative depending on which infinity. Okay? So, we don't have enough time to finish your notes, but we're going to just write down the definition, and then, we'll just do it next time. Okay, so in case you don't know, on Thursday, in your second period class, you're going to a senior assembly. So emotionally prepare, it's Thursday. I thought so. Is it tomorrow?
I thought it was Wednesday. What tomorrow?
What day?
I've been told it was Wednesday.
I thought it was Thursday.
What did you say?
Assemblies are like starting tomorrow.
But no, the assembly's for tomorrow for the lower classmen.
Yeah.
Yeah.
My cousins.
Yes.
I
The
was told
younger,
from student council that it was going to be on Wednesday.
that it was going to be Wednesday?
I've been told from student council.
They told you it would be Wednesday?
Yeah.
Okay, one day this week, you'll go to an assembly, and you'll have a little catch-up time.
Are you at hospital?
Huh?
I'll fill you in.
I thought I had information, but...
I'll fill you in.
Okay, listen, if you need information on time, I was here. So...
Or you'll get arrested.
I mean, it's not during this class anyway. I was just trying to give you helpful, wrong information, so...
Okay, so take all the
to confuse you.